Sir,
Good morning.
Hello. Good morning, sir.
Why coming so late?
Hopeless fellow, sir. That
Huh? Yes, so we'll solve some numerical problem related to this first part of the calorimetry. Do you have any doubt?
no, sir.
question number 6 of numerical, sir.
Huh?
So question number 6 of numerical.
Voice is not clear. You write the message. Okay. Suppose I am giving some problems. Two objects, A and B, having mass M1 and M2, specific heat capacity. Okay, not mass. Suppose you are given having heat capacity. Having heat capacity C1 and C2. Maintained at temperature T1 and T2 are mixed together. Find the temperature of mixture. So in this case, you are free. You can take A is higher temperature or temperature of B is higher. Both are correct, no problem. So you may assume T1 is more than T2, or someone can say, okay, I will assume T2 is more than T1. Final answer will be same. Final answer will not change. So suppose we are saying T1 is more than T2. Then what is heat loss? How will you find? Amount of heat lost by object A. Here you are given heat capacity. So we'll use heat
MST.
capacity into fall in temperature. So this heat capacity into fall in temperature or delta theta F, you can see. So heat capacity is given C1 and fall in temperature is T1 minus T. When heat capacity is given, then amount of heat will be heat capacity into change in temperature. And heat gain and B is cold object. We have, as we have assumed. So what will be here? C into rise in temperature. So it is C2 and rise in temperature is T minus T2. Its temperature will increase from T2 and it will reach till T. Hot object will lose heat from T1 to T. So now according to principle of calorimetry, what will be? Heat loss by hot body will be equal to heat gain by cold object. So what we will get? C1 T1 minus T will be equal to C2 T minus T2. So this T we have to make subject. We have to find T. So C1 T1 minus C1 T. So this T will be one side and rest. So C1 T1 plus C2 T2 will be equal to C1 T plus C2 T. Or T will take common. So this T we have to find. So it is C1 T1 plus C2 T2 by C1 plus T. This will be the temperature of mixture. Now we are given another one when same amount of heat is given to two different objects. A and B of same mass. The rise in their temperature is 2 degrees Celsius and 5 K respectively. Find the ratio of their specific heat capacity. Yes, anyone got?
Findings.
How much?
Sir, 6:2. 3:1.
Three to one, I think wrong. Any other? So in this case, you are given amount of heat is same. So heat given to A and heat given to B is same. Mass of A and mass of B is also same. Of different object of same mass. Rise in temperature you are given 2 degrees Celsius and 5 Kelvin. Specific capacity ratio you are asked. So what will be? This is mass, suppose this is MA or M, suppose this is M. So mass will be same M, specific capacity we have to find, and rising temperature of A. Okay, mass of A, mass of B, specific capacity of B into rising temperature of B. So this is M, this you have to find, rising temperature of this one is given 2 degrees Celsius. This is again M, specific capacity we have to find, and this is 5 Kelvin. So will the 5 Kelvin be equal to how many degrees Celsius?
5 degrees Celsius.
Yes,
5 degrees Celsius.
5 degrees Celsius. And here, rising temperature is there. So whether it is given in Kelvin or Celsius, so it is 5 degrees Celsius. So M cancel. So what is this? SA over SB will be how much? So 5 by 2. So this ratio of specific heat capacity of A and B is 5:2. This is the answer. Okay. Maybe if we have written 6, then it is correct. Okay, here you are given a calorimeter of heat capacity 20 calories per degree Celsius contains 100 gram water at 30 degrees Celsius. In this calorimeter, a copper ball of mass 50 gram heated up to 200 degrees Celsius is dropped. Find the temperature of mixture. You are given specific heat capacity of copper is 0.1 calorie per gram degree Celsius. So in this type of problem, first you have to identify who is going to lose heat and who is going to gain heat. Who will lose heat?
Copper.
Copper, calorimeter. Calorimeter is also made up of copper only. So
Copper ball.
who is going to lose heat?
Copper ball. 200 degrees Celsius.
Copper ball. As the
Copper
temperature
ball.
of copper ball is 200 degrees Celsius, so it will lose heat. Now who is going to gain heat?
Water and calorimeter.
Water and calorimeter both. As water is contained by the calorimeter and calorimeter's heat capacity is given. It is not negligible. If heat capacity is not given or it is given negligible heat capacity, then we will ignore calorimeter or the vessel. If it is given a vessel of negligible heat capacity or nothing is mentioned about the vessel, then we will ignore that. But here you are given. So here calorimeter as well as water is going to gain heat. So separately you will find who is going to lose heat, who is going to gain heat, and then we will apply the principle of calorimetry. So let temperature of mixture be, you can take T degree Celsius, theta degree Celsius, X degree Celsius, whatever you want. So you are free, you can take. Now this heat lost by copper ball. So it is, and mass is given, so mass into specific capacity into falling temperature, theta f or delta theta f, whatever symbol you are using. So mass is 50 gram. Specific capacity 0.1 calorie per gram degree Celsius. And the fall in temperature will be how much? What will be the fall in temperature?
200.
200.
Minus 30.
Yes, any other? It won't be 200. So temperature of this copper ball is falling from 200 till where? What will be the final temperature of copper ball?
T minus 200.
So final temperature will be T. Temperature of mixture here, the copper ball's temperature will decrease from 200 to T degrees Celsius, whereas temperature of calorimeter and this water, which is present in the calorimeter, both will have same temperature. As water is present in the calorimeter, so initial temperature of water and calorimeter will be same, that is 30. So temperature of copper ball will decrease from 200 to T degrees Celsius.
200 minus
Whereas
20.
temperature of water will increase from 30 degrees Celsius to 3 degrees Celsius. So it will become 200 minus T. Now, and this is gram, this is also gram, so it cancel. If you are taking mass in gram, this also, specific capacity also either joule per gram or calorie per gram. So gram cancel, degree Celsius cancel. So what is left? Calorie. 50 into 0.1, that is 5. So 5 into 200 minus T, this much calorie is the heat lost by copper ball. Now we'll find heat gained by calorimeter. So in case of calorimeter, you are given heat capacity. It is not the mass. If mass is given, then ms theta. If heat capacity is given, then C into delta theta. So we will use here C into theta R or delta theta R, whatever symbol you are using. So it is 20 calorie per degree Celsius into T minus 20 degrees Celsius. Its temperature will increase from 30. Its temperature will increase from 30 degree to T degrees Celsius. Temperature of copper ball will drop from 200 to T, whereas temperature of calorimeter or water will increase from 30 degree to T degree. So this T will be between 30 and 200. Temperature will be more than the cold object and less than the hot object. So it is simply 20 T minus 30, this much calorie. Now we will find the heat gained by water. So heat gained by water. So for water you are given mass. Mass of the water is given 100 gram. So we'll use the formula ms theta 1. So it is ms theta r. Mass is given 100 gram. Now specific capacity of water is not given. So what will you use? Yes. What is the specific capacity of water?
4.2.
4.2.
4.2
Joule per
Or
per degree Kelvin.
4.2 joule per gram degree Celsius.
should we use that value? This side we have calculated in calorie, and there you will calculate in joule. Then after equating, either you will have to change in calorie in joule or joule into calorie. So here only we will use
1000
the value of specific capacity in calorie per gram.
Calorie.
And what is the value?
1000.
1 calorie per gram degree Celsius.
1.
Calorie per gram degree.
Okay, so it is 1 calorie per gram degree Celsius. And rise in temperature will be same, that is T minus 30 degrees Celsius. Its temperature will also increase from 30 to T, where it is contained in the same, kept in the same calorimeter. So it is 100 T minus 30. Gram gram cancel, degree Celsius cancel. So this much calorie. Now we'll apply the principle of calorimetry. So according to principle of calorimetry, what will be? So this is the heat loss, and this both are heat gain. So heat lost by copper ball, that is 5 into 200 minus T must be equal to 20 into T minus 30 plus 100 into T minus 30. So T minus 30 will take common, then 100 plus, so it will become 120 T minus 30. Now you solve and get the value of this T. So 200 minus T, this 5 will divide, then how will it become? 24. Is it correct? 5, 24 time, yeah. So 25 T will be equal to 920. So temperature of mixture will be 36.8 degrees Celsius. Right now, 5 there.
Yes, sir.
Yes, 36.48. Okay, vessel of negligible heat capacity. Okay, suppose you are given a vessel of negligible heat capacity contains 200 gram water at 20 degrees Celsius. When a metal ball of mass 100 gram heated up to 150 degrees Celsius is dropped into it, its temperature falls up or drops up to 28 degrees Celsius. Find specific heat capacity of metal ball. Zero point 0.22 gram per kg. How this unit came? What is the So in this case, who is going to lose heat? So who is going to lose heat? The metal ball is going to lose heat and water is going to gain heat. You are free, you can take as it is given, find specific capacity of the metal ball. You may find in calorie per gram, but if it is mentioned here, find specific capacity of metal ball in SI unit. You can find in calorie per gram, after that you change, no problem. Suppose find specific capacity of metal ball in SI unit is mentioned. If it is not mentioned, then also we should express the result in SI unit only. That is expected by the board, that you are supposed to, if nothing is mentioned, you are supposed to express the result in SI unit. Okay, you are free, you can take in calorie per gram, but after that you will have to change it in SI unit. So, here heat lost by metal ball. If you have taken, let okay, specific heat capacity we have assumed. Capacity of metal B, suppose you have taken calorie only, no problem, per degree Celsius. Then what will be the heat lost? Its mass is 100 gram. Specific heat capacity we have assumed as calorie per gram. And what is its fall in temperature? The initial temperature is 150 and final temperature is 28. So 150 minus 28.
122.
122 degrees Celsius. Okay. So it will become 122. So 122.00 into S. This much calorie will be the heat loss. Now water is going to gain heat. Heat gained by water. Mass of water is 200 grams. And this much we have taken in calories, so here also we take calorie only. 1 calorie per gram degree Celsius. And rising its temperature is from 20 degree to 28 degree. So 28 minus 20. So it is 8. 8 to the 16. So 1600 calorie. Now according to principle of calorimetry, what will be? So 12200 S will be equal to 1600. Both are calorie only. It is over. So this S we got 0 cancel, 16 by 122. So this much value you will find. How much you got after dividing? 8 over 61. So 0.1 something you will get, no?
0.13.
0.1. How much?
0.13.
0.13. Okay, so we write specific heat capacity of metal is 0.13 calorie per gram degree Celsius. Now you are asking SI unit, suppose, then we will change it. 0.13, how much? 1 calorie per gram degree Celsius? 4200 per kg per Kelvin or degree Celsius. So whatever you will get, that will be the answer. Okay, already time up. So you will leave up to here. Now you solve the problems given in your book. If you will not have any doubt, then next day we shall start change of state. If you will have any doubt, then next day you ask. But you solve your problems in book honestly. Okay,
Thank you,
shall we
sir.
leave now?
Thank you, sir.
Thank you, sir.